Look at something red right now. A shirt, an apple, a stop sign. That color is not out there in the world. Light doesn't have color. It has wavelength, a physical measurement like the length of a wave in the ocean. Red doesn't exist until something with a brain shows up to invent it. You've been hallucinating in color your entire life. And somehow, it works well enough that you've never noticed. Here's the actual sequence. Light hits your eye at a certain wavelength, say around 700 nanometers, a distance smaller than a speck of dust. Your eye has 3 types of color-detecting cells, called cones, each tuned to catch a different range of that wavelength, roughly short, medium, and long. Your brain compares the signals from all 3 cones, does some math you're not aware of, and outputs a feeling. That feeling is red. The wavelength is real. The redness is manufactured, entirely inside your skull. This idea, that color comes from 3 overlapping signals, not one, is called trichromatic theory. It was first proposed in 1802 by the physicist Thomas Young, decades before anyone could look inside a living eye and check. Young guessed that 3 types of receptors could explain every color we see, from mixing just 3 signals, the same way a TV screen makes millions of colors from only red, green, and blue pixels. He was right. It took almost 200 years and actual microscopes to prove it. Here's where it gets stranger. If color is invented by the brain, does everyone invent it the same way? Not even within the same species. The genes for your red and green cones sit on the X chromosome. Men have 1 X, so they get 1 version of each cone. But women have 2 X chromosomes, which means some women inherit a normal version on one and a slightly shifted version on the other. That gives them 4 distinct cone types instead of 3. Around 12% of women carry this. You'd think that means they see extra colors automatically. Mostly, they don't. Having the 4th cone isn't enough. The brain still has to learn to use that extra signal. And most brains never get the training. Only a handful of people on record have ever shown it actually working. So color diverges before you even get to language. In 1969, linguists Brent Berlin and Paul Kay studied color words across dozens of languages. They found something odd. Some languages have no separate word for blue. They use the same word for blue and green. It's not that speakers of these languages are colorblind. Their eyes work fine. But without a word splitting blue from green, some studies suggest people are measurably slower to tell the 2 apart. The category itself sharpens or blurs what you notice. Meanwhile, some languages split what English calls blue into 2 completely separate basic colors. The way English treats pink and red as different, not shades of one thing. So imagine you were born without cones. True colorblindness, seeing only in shades of grey. The world wouldn't look empty to you. It would look complete. You'd never miss red, the same way you don't currently miss whatever colors other animals see that you can't. Like the ultraviolet patterns bees use to find flowers, invisible to us, obvious to them. There's no true version of color hiding underneath. There's just whichever version your particular set of cones and your particular language taught your brain to build. So the next time you see red, you're not detecting a fact about the world. You're watching your own brain finish a sentence that light started. Different eyes, different languages, different brains. Slightly different sentences every time. And somehow, every single one of them feels completely real. If you like what we're doing here at Science for Starters, consider subscribing to our channel and check out our other videos. Got a topic you want us to dig into? Drop it in the comments. Happy learning!